in any look at both risk and return, one of the first things we need to do is to review some of our measures from our statistics background. These are the things that we're going to extend here to use to talk about both risk and expected return. Now, the problem that we put out here for you, it says you're a financial analyst for CKC Corporation, and you've provided a forecast that's demonstrated below here of the economy and the performance of your company in the economy that obtains. Use this information to illustrate the expected rate of return and the risk as measured by the standard deviation of those returns. So what we've got here is the following scenario where there are three different scenarios that you envision that can happen in the future: recession, normal growth period, or prosperity. Now, the likelihood of each of those scenarios is given here. So we expect normal growth 65% of the time, recession 15%, and prosperity 20% of the time. In each of those cases for your company, these are the kinds of rate of returns that you would anticipate seeing: a drop of 2% in recession, an average return of 12%, and a 22% in the case of prosperity. And what we need to come up with are basic summary measures. The first of these is the expected value, or the mean, the variance, and then we want to go from variance to talk about standard deviation because it's in the same units of measurement as the expected return. Now, the formula that we're going to follow over here for probability distributions are provided to the right. What we're looking for in the case of expected return, or the mean, and that's all that this is the notion of the mean, is we're going to add up the probabilities of each outcome times the outcome itself. So we'll add to that the probability of normal growth times its return, the probability of prosperity times the return in the case of prosperity. So to do that, to take these probabilities times these outcomes, we do have a function that we can use in Excel. So I'm going to go to the function wizard here, and you want to go under the all heading, and we're looking for a function called sum product. It says add up these multiplications that have gone on. So if you scroll your way down here, you find something called sum product. Within sum product, it wants to know what are your arrays that you're going to be multiplying. Well, we're multiplying, as you can see here, probabilities times outcomes. So array number 1 is going to be my probabilities. Array number 2 is going to be the return in each of those corresponding instances. And when they add up, it's going to give us an 11.9% expected return as given by the formula for expected return. So on average, 11.9% is where you anticipate that you're going to be. Now, that's what we're going to give for a measure for return, is we're going to use the expected return. Now, we have a couple different risk measures that are provided here. The first of these is the variance. But to get the variance, you can see the formula up here for variance. It's given by the symbol sigma squared. And what it does is it takes the probabilities of each outcome, each state of the world that you could have here, and it multiplies it by the difference between what happens in that state of the world and the average. And it's going to square those, because if we didn't square it, this thing would just be 0, because you'd have some things above the mean and some things below the mean, and weighted by the probabilities, it would just come out to 0. So I've created a little column over here that looks at that square deviation component. So we want to simply set this up so we can copy and paste, so let's do this carefully. So it's going to equal, and in parentheses, what we want here is the return, and we want to subtract from that the mean. Now I'm going to want to do this and just copy this from this row down to the next row, so I'm going to need to lock it in there in row 10 of column C. So I'm going to put a $sign in here, so it's C$10. I can close the parentheses, and I'm going to raise it so to the power of 2. So I'll choose that little hat symbol above the 6, which is the exponent symbol, and square it. And when I do that, I get a number 0.01932. Now, I can copy and paste that in place for these others. And when I do so, it says, okay, it's a very, very small difference. Even out to 5 decimal points, you don't notice anything in the case of normal growth. You'd have to go even further, and so on down to prosperity. Now, once I've got these components in here, I can apply this formula given over here for variance. And again, like we had before, it's the sum of products. So I can go here to my most recently used, since I had just used that sum product function, and tell it OK. The array number 1 is again going to be the probabilities, but array number 2 that we have in this case is the square deviations, this column that we just created. And it's going to give me a variance of 0.004939. Now, it's put it in here as a percent, but it really isn't a percent. So let me go back and change this so we can talk about what it is. It's just a number. And it's a number, we'll put it out here to several decimal points to get a look at that. The reason it's not a percent is that when we went and squared these items right here, these are squared percents. And so that would be the units of measurement, a very difficult one to interpret. And because of that, we have a preference to deal with a measure called standard deviation. And standard deviation is just given by the symbol sigma here, and it says let's just take the square root. Because when we take the square root of the number here, we also take the square root of the squared percents, and it leaves us back with percentages. So you can do this in either of two different ways. One, you could take the variance and raise it to the 1/2 power, as we've illustrated up here in the formula, and that will give it to you. Or you could use the function square root, SQRT, that's given under the function wizard. Either one is going to give you the same thing. I'll just take the variance, and I'm going to raise it again, the little hat. I'm going to raise it to the 1/2 power. And when I do that, I get a standard deviation of 7.03%. Now, you can go ahead and take that information on and begin to talk about it in terms of, say, a normal distribution. In a normal distribution, if you recall, we have within one standard deviation of the mean, we have roughly 68% of the observations. Within two standard deviations of the mean, roughly 95% of the observations, and so on. And you can get an interpretation of what that means by using your expected return and your standard deviation. But those would be the base summary measures that you certainly want to be able to calculate.